Ladies and gentlemen, it is 3 p.m. today and it's mid-infrared day in EPIC. Welcome everyone to another chapter of the season 3 of EPIC Online Technology Meetings. Today, mid-infrared technologies. Light is key to understanding the purity level of every solid, liquid, or gas, close up or far away. That's because each molecule absorbs specific discrete wavelengths. But there's a complication. Luckily for us, planet Earth is filled with water, but humidity levels change constantly. And that directly impacts our ability to precisely detect other molecules like CO2. Here comes the solution, mid-infrared, where molecules absorb very specific wavelengths that water doesn't, specifically between 3 to 12 micrometers. Mid-infrared is definitely booming, which reminds me of the defense sector. When detecting explosives like TNT from a distance like 500 meters, independently of changing weather conditions, saves lives. Or take the automotive industry. In normal times, an estimated 250,000 people die each year on the road due to drunk driving. Europe has some of the highest figures. We have laws about using seatbelts, but imagine a mid-infrared sensor inside the car could disable the engine if it detected alcohol on the driver's breath. Such a simple solution, saving so many lives. Sensors inside the car can monitor useful things in real time, adjusting ventilation if CO2 or NOx levels build up inside. Now, on the detection side, we already have champions. New infrared technologies from Spain or Vigo in Poland immediately come to mind. However, as well as cameras, you often need to illuminate the object. We call this active imaging. 4 years ago, Leonardo, a giant in the European defense and aerospace sector, acquired a US company called Daylight Solutions. Why? Because quantum cascade lasers at mid-infrared have been pricey, yet they are key to mid-infrared active imaging. So this acquisition triggered a rapid expansion for all the companies involved with developing quantum cascade lasers. So on February 3rd at 3 p.m., I want to explore some of the applications that will accelerate development of mid-infrared. So expect the unexpected when we talk to Cees Ronda from Philips about medical diagnosis based on breath analysis, or look out for Opus RSC, the makers of really smart transport systems. I think I detect you want to sign up for this online technology meeting right now. So see you on the 3rd at 3 to explore some great opportunities. So it is the 3rd at 3 and it is 3 p.m. and the mid-infrared community is here next to me. I have from Tokyo to Madrid to Rochester. I have nanoplus on the lasers. I have the detectors from Vigo. I have everything and the end users to make business today. It's going to be a fantastic meeting. I keep saying things are really difficult these days. It is very difficult time for everyone, but we are almost there. We are almost over. And during this time, EPIC really made a huge push for having the EPIC experience online. But having said that, I can't wait to travel. And I know it's politically incorrect to say this. I can't wait to give a hug to all the EPIC members. I really can't wait. On behalf of a fantastic team of people at EPIC, 15 employees who organize events, provide access to a network, help companies who raise capital, had the biggest website in Photonics to find a job, jobsinphotonics.com, and provide the members with market data. It is a pleasure to share this meeting today. Today is the mid-infrared technologies. I also have announced the rest of the meetings for Q1 2021. Pay special attention to the one that we have on the 15th of March, LiDAR 2.1. We really have big surprise on that meeting. But important, if you see any interesting technology on these meetings, please register as soon as possible online so we can make sure that we engage you with the rest of the supply chain at the meeting. And also, many people know this, but not everyone. For this year, 2021 is a very special year for me. EPIC also includes quantum technologies in our portfolio, and we start strong. We start with our online quantum technology meetings. We are addressing every technology and market from defense to communications, if you are interested in quantum technologies, if you want to invest in it, if you have no idea what it is, but you think your sensors, your detectors, your laser could have a role, join these meetings. Let's do quantum business. And that's it. Let's talk about mid-infrared today. Today, I would like to acknowledge the support of our media partners, Photonics Views, Electro-Optics, and Gas Optics. Thank you so much for the constant communication of what we are doing here. I'm just working like a dog, Hannah as well, and I'm so happy that you are acknowledging this and making sure everybody knows what we are trying to achieve. But also, this meeting today wouldn't be possible without the support of our sponsors, Thorlabs. If you're looking for any laser detector, any component or stage, Thorlabs has some of the best products in the market and also the best people to help you design the fantastic setup. But if you're looking for optics, for high fluence, high power, ultra fast lasers, you need IBS coatings on those optics, and you should go to Optoman, all the way from Lithuania. They provide fantastic IBS coatings for laser optics. If you are looking for money in photonics, this is great because we have Vigo Ventures. Vigo Ventures is looking to invest in photonics, really. So you have a company and you're looking to raise capital. We have an investor who is actively looking for investment in photonics. I love them. Chenkovie Parcho. APE. If you're looking for a device to actually can do pulse stretching ultra fast laser, or actually can do any kind of autocorrelation of the signal, APE has one of the best system for integrating fibers for ultra fast and high power lasers. Asphericon all the way from Jena. Freeform optics and spherical optics with the highest resolution and the minimal error when it comes to metrology of their own optics, when they make a difference. But if you're looking for mid-infrared fibers, you have to go to Berlin. Art Photonics develops fibers for the mid-infrared, actually for any wavelength between the visible and the long infrared. If you're looking for fibers for any kind of lasers or sensing or medical application, you have to talk to Slav Artyushenko, you have to talk to Art Photonics. If you're looking for any laser at any wavelength, you have to talk to Nanoplus. Nanoplus is one of the key companies who's setting up the revolution of mid-infrared, but they also provide any laser at any wavelength from the visible all the way to the long infrared. Nanoplus is a key company in the segment, but Iridian has one of the best wavelength selective optical filters in the visible and SWIR range, and they have been doing this for about 10 years. When it comes to mid-infrared technologies, they have done great job in non-dispersive and photoacoustic spectroscopy sectors. And finally, Actar. So you're looking for black coatings now. You're looking for black coatings. These are the beta blank technology of Actar Advanced Coatings is the best to actually have full absorption on a material of any light. And that's all. Thank you so much. And now I can breathe because I want to give the floor to Ana Gonzalez. Dr. Gonzalez, what's in the menu today?
Hello, everyone, and thank you, Jose, for your kind introduction. So yes, I am very happy to be here today to talk about mid-infrared photonic technologies and applications. So as you can see here in the agenda, we have a very interesting and complete agenda. We will talk about medical applications, mid-infrared cameras, security applications, but this is just the starting point. These talks will trigger very interesting discussions with all the companies attending the meeting that are ready to participate in the discussion. So thank you very much for registering. Yes, at EPIC meetings, the needs and challenges of end users of the technology are the starting point to push collaborations between the supply chain. And today we have a great list of end users in the room, such as Solar Vibes, NASA, Huawei, Leonardo, Philips. So we have the companies offering mass spectrometers or kind of lasers, optics and micro-optics, system integrators, companies doing equipment for automation, packaging, software, R&D organizations. Then I would like to mention as well some of the initiatives in which we are participating, like the pilot lines in photonics that are participating in this meeting. So these pilot lines are working together, developing standard solutions for manufacturing of photonic devices, such as MWIR, which offers prototyping of mid-infrared optical modules for chemical sensing, but also MedFab, the pilot line of medical applications covering in vivo and in vitro diagnosis, and offering manufacturing, testing, and validation and regulatory compliance. Also PICSAP, a pilot line that offers standards, packaging and assembly solutions for photonic integrated circuits, with focus on developing processes that are compatible with larger volume manufacturing. And also very linked to the supply chain of mid-infrared, we have Fabulous, that is for high volume fabrication of freeform micro-optics. And the new Photon Hub. Photon Hub supports European companies that are not experts in photonics to develop new products based on photonic technologies, financial and business coaching, and also technical training. So yes, if you want to know more about any of these initiatives, please feel free to contact us. Back to you, Jose.
Ana, enhorabuena. Congratulations for all the amazing job you have done over the last 5 years connecting the mid-infrared community. Amazing job resulting on these fantastic meetings on the supply chain. This slide only corresponds to the companies who registered for the meeting today. So you're an EPIC member and you are missing your logo there. It is just because you didn't register, but we never forget about you. This meeting is live streaming YouTube. So hello, YouTubers. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asa.com, and I will make sure I do the introduction. But also you can use the chat in the YouTube channel. Any question that you write there, I will read into the room. And this, of course, also valid for the people in the Zoom room today. We have an internal chat. Use it to do business during the presentation. This is a unique opportunity, but also you miss that opportunity. If you want to get in touch after the meeting with any of the participants today, drop me an email and I will make sure I do the introduction. With this, I would like to start the meeting, and there is no better way to start the meeting than to go to case Ronda from Philips. And the reason we want to go to case Ronda is because we really want to understand how to make Philips great again. I really also want to understand how they are addressing the mid-infrared technologies for the life science sector, and especially the breath exhaust monitoring. Thank you very much, Cees. Thank you all for being with us today. The floor and the attention of everyone goes to Philips.
Okay, so let me share my screen once more. Is this the correct screen? This is it. Yeah. Okay.
Yes.
So first of all, thanks for the invite. I will make it large. And what I would like to do is I would like to tell you a bit about how we are dealing with innovation. And so how of course I have only 6 minutes, so I will guide you through 2 examples where we also are looking at potential mid-infrared applications. Yeah, but first, let's say what Philips is doing. We are a healthcare company in the meantime, so we have, of course, we are still great as a company, so also as a healthcare company. And this is a response to you a few seconds ago, and we are, let's say, we have organized our business along healthy living, prevention, diagnosis, treatment, and home care. Yeah, so here you see some of our business. You see our businesses below, and I will give you an example about sleep and respiratory care, but also about, let's say, some kind of process which we could embark on their population health management. So I'm looking at some technical developments in optical sensors, also a bit about roadmaps and driving industries, looking at gas sensors, multispectral sensors, and I will also touch upon societal challenges such as environmental pollution, but also greenhouses to ensure, let's say, that we do produce as human beings enough of food, yeah, to nurture the world population. This is not a Philips, not necessarily a Philips driver, but it is an important driver for mid-infrared developments. And so many of the sensors, let's say, where we are mainly interested in, let's say in this talk at least, are driven by other industries, automotive, for example, and mobile devices. Yeah, and also in many of the cases, we as Philips are not driving the development of sensors anymore, given the relatively low numbers, which is especially true for personal health. And so we need to accept that the roadmap is driven by other industries and also other applications in terms of costs and performance. Having said this doesn't mean that we do not want to apply sensors. We actually need them. Any company that wants to go digital will also need sensors because they are the interface between the physical and the digital world. But it means that we have different models of how to develop them. And that is why it's also very good to be connected to communities like the one we are in now. Yeah, so I would like to talk about optical gas sensing, and for example, we have a business, yeah, which also does analysis, for example, of breath, people breathing. We had the business which we're now spinning out, which is also which was looking at indoor air quality, and but for instance, CO2 is an important gas also to measure in breath, and it has additional relevance in COVID-19 times because you can also use it as a proxy for aerosols in indoor air. So we are looking at, let's say, so, and you, of course, we want selectivity, and the selectivity can be, can be tuned, for example, by selecting a suitable wavelength, and here you see some of the gases where you may wish to look at, and also the wavelength where, let's say, where there is a strong absorption, and this is in the mid-infrared. Yeah, and so you can do this, for example, by applying a broadband infrared source and a pass filter. Yeah, and of course a detector. You, as a relatively new development, is at least industrially wise, is photoacoustic spectroscopy, where the selectivity is by the light source, and where you don't detect any light, but you detect an acoustic response, which you can, for example, use a MEMS microphone. And so we see drivers here, and let's say one of the drivers is breath detection, yeah, and but also in some of the cases consumer applications, for example. When we want to measure CO2 concentrations in indoor air to judge the indoor air quality, a driver could be, for example, also greenhouses, where CO2 is also a compound which you would like to add to stimulate growth of vegetation. Yeah, and drivers are also further miniaturization and integration, especially. We would like to, let's say, it would be important to be able to detect more gases per sensor chip. Yeah, and of course, costs are important. And here you see some examples. You here see an example of a CO2 sensor, let's say, incorporated in a smartphone, which gives you the CO2 concentration immediately. In this case, it is already relatively high. Yeah, the background concentration is in the order of 400 ppm. So there, let's say, there is still a lot of room for innovation, and let's say, and as I argued, yeah, it is not easy for us, and in fact, we would like to rely on corporations there. Multispectral, that's another part. Multispectral sensing, or which is a kind of a derivative from hyperspectral sensing or sensors, because we do not, in multispectral, we do not use necessarily the complete optical spectrum, so we can also pick selected wavelengths, and from this we want to gather enough of information. So it is, for example, monitoring the health status of crops. That's an example which is not in our immediate interest. Waste sorting is not in our immediate interest. Yeah, but plastics may have different responses also in the infrared, for which you can then choose for waste sorting. Body sensing, including body liquids, I have an extra slide on this, is of interest. And nutrient characterization is also an interesting application. Here you see an example, yeah, of how this could look like. Yeah, so this is a smartphone with a multispectral sensor in it, which can, for example, detect the ripeness of, in this particular case, strawberries. Yeah, so that is also an application which I would expect gets a lot of consumer attraction once it would be available. Yeah, here's some needs. Yeah, so especially miniaturization, but also an increased number of wavelengths per chip, yeah, to make them more generally and more to make them suitable for more than one application only. Yeah, a broad spectral detection range beyond silicon photonics, as is here. Yeah, and there, of course, mid-infrared comes into play, and some other features like the spectral width of optical filters and broadband light sources, which would need to be developed. Yeah, so in here, let's say, I'm sure most of you know this. Yeah, but what you typically do, especially in this wavelength range, is that you measure overtones of molecular excitations. Yeah, so, and this can be used especially with more than one wavelength, to discriminate a number of different compounds, for example, in breath or also in a liquid, in a body liquid, for example, ideally even through the skin. The process is that we use near-infrared spectroscopy at selected wavelengths to identify functional groups. You will also need some kind of a database of the optical features, let's say, of the compounds that you would like to detect, so that serves as a kind of a ground truth. And you use, let's say, all kinds of artificial intelligence routines, mainly to determine the presence and concentrations of compounds of interest. So this is an example in the near infrared, for example, for methanol in water, where let's say, so this you could also see as some kind of a ground truth determination. But you could do the same for ethanol, for example, in the much farther in the infrared, or even for glucose in water and maybe also in blood. So this is let's say, this is to reveal you some directions where we are interested in looking. So we are interested in let's say, in breath analysis, but also in, let's say, in body liquids, ideally through the skin. So that ends my presentation. I hope I was within the 6 minutes.
Thank you very much. Yes, you were inside of the 6 minutes. Very interesting presentation. So yes, well, first of all, you already said some challenges, no, such as new filters and also miniaturization and others. I mean, could you maybe highlight one or two of them so we can try to find collaborations for you here?
So I'm afraid, and I did not get the question completely.
Okay, sorry. No, it's just if you could highlight one or two challenges for the technology. I was now looking at the challenges that you were presenting for your multi-spectral sensors. So maybe you would like to highlight a couple of these challenges to find collaborations inside our...
Yeah, so of course, this is partially, it is at least public information, but an important challenge would be, it's publicly known, it would be, for example, to sense body liquids through the skin. Yeah, this can, for example, be glucose or others. Yeah, and the more general phrasing is in a non-invasive manner. Yeah, there was also a question in the chat. So for consumer applications, we do not embark really on consumer application for CO2. Yeah, but for example, in our sleep and respiratory care business, measuring CO2 is an important thing.
Okay, so thank you very much for the answer. We have plenty of questions for you in the chat. So the first one is from Johannes from nanoplus. Johannes, would you like to make the question by yourself?
Okay, yes. So the question is, I'm not quite clear what volume markets you're looking for. What is the typical size Philips would be interested in?
Yeah, of course, that depends strongly on the application. Yeah, but the sizes are, and let's say, I also do not have the perfect freedom to reveal here all kinds of numbers for an application. But for example, we something like 100,000 sensors or such products per year would already be quite a decent number. Okay. So we are not talking about millions, yeah, because if we would talk about millions, we could also drive the market. Yeah, so in many of the cases we cannot drive the markets because compared to the total turnover in a specific kind of sensor principle, yeah, our numbers are simply too low.
So we need sources for this light sources. So perhaps we can talk about it because we have all kinds of light sources for this.
That would be very interesting. Yeah.
Okay.
Thank you.
Thank you.
Very good. We have more questions in the chat. Wilfred from SUS Micro-Optics, what is in your mind?
Thank you, Anna. Very interesting. Mid-infrared is coming, is there. The question from my side is when you said miniaturization, so what dimensions do talk about? Is it millimeters, sub-millimeters, or you showed a mobile phone? I mean, this is probably still very challenging to do. So what are the main components that will be difficult to miniaturize? Goes in the same direction like nanoplus asked. So because we do a lot of miniaturization at Cees Micro-Optics for optics, the question is, what is the most difficult part to miniaturize? Is it the optics, or the source, or the detector, or the filters? Can you elaborate on this?
Yeah, so that is a bit difficult for me. Yeah, but let's say, of course, how far miniaturization is needed also depends on the application. So I would expect that you also see developments in the external world where, for example, people are already developing miniaturized spectrometers. Let's say a very compact size. But let's say in the end they should be. In the end, the miniaturization encompasses all parts, including the driving electronics. Because I would expect that, for example, when we talk about a spectrometer, we can miniaturize it, especially when it is multispectral and not hyperspectral. And let me think. Yeah, so that is essentially it. So it would be the complete unit but it also strongly depends on the applications. And if we, for example, talk about oxygen sensing, that is, let's say there it is already for some reason it's already quite difficult, at least when it's based on optical absorption, for example, because the absorption is weak. There we may need to think of different concepts, which are being developed. But ideally, let's say, especially for products which are in contact with patients or consumers, we would like them to be relatively small.
Yes, but I wondered which component is the most critical to get or to miniaturize or to make small. So which or maybe we do that offline later.
Yeah, it depends on the application, because it could, for example, be a very simple remark would be that the power would be largest. And because I would expect that light sources and also miniaturized spectrometers will be available anytime soon.
I see.
In very compact in a very compact shape. So it is also about let's say the complete unit, and it is application dependent.
Okay, thank you. Maybe you can have this conversation offline because we have a lot of questions. So Le Verret Flore, Samuel, do you want to make the question by yourself? Hello, Samuel. Okay, maybe Samuel is not ready.
Yes, sorry.
Hello.
So, as you mentioned, the need for broadband light sources, I was wondering if there were an interest in mid-infrared supercontinuum laser sources. But of course, I guess that this question is associated to the miniaturization question, which is, as I understand, compulsory.
Yeah, in the end, it also we are, let's say, for these applications, of course, we are interested in mid-infrared light sources. Let's say, maybe not necessarily lasers, because let's say in many of the applications we at least do not need the coherence. But we may need, let's say, another spectral feature, which is, for example, that the light source is narrow banded. And there is also a question about the complete about, let's say, the wavelength region and fiber optics. But so that again depends on the application. But I would expect it for many of the applications, let's say, we would not need to go beyond something like 5 microns.
Okay, and do you have wavelength band of interest? Because you say up to 5 microns, which is of course of great interest for Le Verret Flore, because we are specialized in fibers from visible range up to 5 microns, but we could talk about that later.
Yeah.
Okay, very good. So then next question, Eric from ST Microelectronics. Would you like to make the question by yourself, Eric? Hello, Eric. If not, I can read the question. Okay.
Yes.
Go ahead.
I was a bit confused about the wavelength range that you are speaking about, because the title is mid-infrared, and you have shown something related to near-infrared. So can you comment what's the main?
So in the mid-infrared, we are also in, so gases, for example, is clearly mid-infrared, if this is all feasible. Yeah, so that was also in one of my slides. And for body liquids, we may also need to go beyond what I've shown. Yeah, so that is also a potential other application.
Okay, thank you very much for this. Okay, thank you. Last question. Jason from Iridian, would you like to make the question by yourself?
Sure, thanks. Thanks very much, Hannah. Thanks, Cees. You mentioned multispectral imaging and the use of different optical filters in your systems, the NDIR and the photoacoustic spectroscopy. But for the multispectral, are you looking at needs for filter wheels with different individual filters, or multispectral, multi-zone filter arrays?
So we will prefer the last, because we don't like moving parts, for example, especially not in a compact and consumer device. But also, let's say, so ideally, we would like to have it completely optical based without the filter wheel or something like this.
Okay, we should talk about that. We have both those capabilities. So
okay, good, excellent, thank you.
Okay, and then now the last question. Okay, Slava from Art Photonics. Would you like to make the question by yourself, Slava?
Yes, I think there is a well-known fact that all the photonics devices in visible range is already using quite often fiber optics. We simply are one of the major manufacturers of infrared fiber optics, which covers a range up to 16 microns. So any components in devices can be connected by fiber optics. So, Anna, can I show my slide now?
Yeah, sure.
Yeah, okay. Just a moment. Okay. So, do you see it now?
Yes.
Yes, if you can go to presentation mode. If not, it's okay.
I think it is in presentation now. Anyway, you can see here that the whole range, from 1 micron up to 17 can be covered by flexible fibers of 3 types: chalcogenide, pure fiber, and then, we also started to manufacture hollow waveguides. So that's why any kind of flexible contact between infrared source, infrared detector, complete device, complete spectrometer or sensor with media, not a problem to manage in partnership. Infrared imaging is one type of application for mid-infrared photonics. Infrared spectroscopy, process control is another segment of the market. And the third is really, let's say, delivery of power for CO2, CO lasers, for quantum cascade lasers, of course. So that's why, as soon I promise to be limited to 1 minute, I will not overload you by too many slides. Only I'm happy to mention that we were recently awarded, by, let's say, special prize, like a global leader in mid-infrared fiber optics. So anything which needs flexible delivery from the target, because it can be a stream of milk, can be wastewater, can be measurement of, let's say, water in soil. Everything we can provide with fiber optic flexible solutions. So that's why we are very open for partnership.
Okay, thank you.
What is the Slava? What is the key application that that is the one that you think that is the killer one for mid-infrared fibers?
Okay, for the size of market, I should say it was not developed up to now, but I see enormous opportunities in the mid-infrared imaging. Because just to give you one figure, today market of endoscopy is about $40 billion. If it will be only 1% of this market realized with infrared endoscopes like this, then it will be a chance, you know, for doctors to see tumor on the stomach wall. Tumor is half a degree warmer. So potentially one of the biggest area. Second, which is today the biggest for us, it's remote spectroscopy process control used for milk industry, for petrochemical industry. And here we are really, let's say, sure in great future as devices can be sized like it was shown by Cees. It can be palm size detectors, which are specially used to see, I don't know, COVID patient, because you can analyze exhalation of the patient in real time with, for example, quantum cascade lasers from nanoplus. So we have one project with Johannes already, and it's for medical purposes. So that's why maybe anything in life science will be the biggest market. So.
Okay, thank you very much, Slava. My congratulations for the award, very, very well deserved. Thank you very much, Cees, for this incredible presentation and for the discussion time. So let's move to the next speaker now. So it's my pleasure to introduce Jeremy from Daylight Solutions. So please, Jeremy, if you want to share your screen.
Okay. Good morning and good afternoon to my colleagues in the US and Europe. I see a few familiar faces out there. Okay, how's it coming through?
Very good, you can start.
Okay, well, thank you again for the invitation to be here this morning or afternoon. You know, I'm with Daylight Solutions. I've been with Daylight for about 11 years. And in that time, I've seen a sea change really in kind of the investment and interest in mid-infrared. And I think it's a testament to the, the audience we have today, just, how much more interest there is where, the likes of Philips, coming to the table, looking at, mid-infrared as a potential opportunity in the life sciences sector. We certainly at Daylight have really been marching towards taking mid-infrared laser sources, quantum cascade laser technology into a multitude of markets, including life sciences, defense sector, as well as basic research. So I come today kind of representing our commercial, scientific, and instrumentation line of business. Daylight Solutions started operations at the very end of 2004, so we just finished our 16th year. So I've been there for about 2/3 of that time. Tim Day and Paul Larson were our co-founders. Tim Day is still the captain of the ship. He's still with us. We work with him on a daily basis. So it's really still fun. That core group of people at Daylight is still there. We're still all very passionate and energetic about really bringing these kind of turnkey external cavity quantum cascade laser sources into a variety of different markets. So today we've grown quite a bit from the small startup when I joined. It was just a handful of people. We're now at over 250 families at Daylight, spanning a couple of different sites in the US. We're since 2017, we were acquired or merged with Leonardo DRS company, who has a parent company based out of Italy, Leonardo. And I think there was an introduction video there at the beginning, Jose. So thanks for the shout out there. That was certainly a very good opportunity and something that was very welcome from our side. It was a very good partnership. It has been a very good partnership for us. It's fueled a lot more investment into our portfolio and technology. As you can see in the upper right-hand corner, this is the new facility that we opened up at the middle of 2019. So we're greatly expanding our manufacturing capability. So we're now occupying close to 70,000 square feet in that one facility, and we've acquired additional businesses in the U.S. since then. So we're growing quite substantially, in the past couple of years. We've invested heavily in our patent portfolio, so we're constantly innovating, putting quite a bit of R&D investment into new technologies, roadmap, where these kind of source engines, spectroscopic engines, will go into different markets. And very proud of the fact that just in our scientific commercial business alone, we've fielded over 1,000 laser systems. Most of those have occurred in just the last handful of years. So we're really, starting to pick up production rates quite substantially. We have some product lines that are well over 1,000 per year. So not the volumes of hundreds of thousands, but certainly, moving up the ladder. And I think we're starting to see a little bit of economy of scale. And as we get into different markets, prices, costs obviously become a lot more sensitive. So Daylight's portfolio, we have a variety of different offerings, starting at the kind of the basic component level. We work either with suppliers or we make them ourselves, depending on the nature of the component. Being a part of Leonardo DRS, we have quite a bit of detector fabrication capability in the US, sensors, imagers, for example, as well as optical and electronic capability. We build, I think we're most well known for kind of our turnkey tunable external cavity quantum cascade lasers. That's the kind of that middle section there. So we have a variety of different types of lasers depending on the type of application. Those are mostly purpose built to go into kind of research applications, benchtop applications. We also have a quite substantial emerging OEM business where these lasers are kind of purpose configured for an application, anything from semiconductor inspection to life sciences applications. And at the very top, we have, since about 2014 or 15, we've introduced turnkey analytical instruments based on these tunable quantum cascade lasers. And today, kind of the most distinguished products in that category include what we call our Colpeo liquid analyzer. So this is where you're looking at a liquid coming through and analyzing in real time spectroscopy in a particular mid-infrared spectral band. And then our Sparrow microscope. This is a wide field imaging, so we're illuminating many pixels at once. And that allows us to do very high throughput, high resolution screening of anything from tissue samples to blood diagnostics to looking at materials analysis in pharmaceutical ingredients, for example. So a number of commercial markets that we serve today include semiconductor inspection, biomedical. This is, we're looking at significant inroads into kind of digital pathology, that space. Something would be interesting to talk with a colleague from Philips at some point. This label-free or labeled mid-infrared version of histopathology. Rapidly expanding into the life sciences sector, particularly with the liquid and analyzer as well as the microscope. Microscopy, both in terms of nanoscale imaging, so a very significant growth in the last 5 to 10 years on using mid-infrared coupled with atomic force microscopy tips. That's a very strong and rapidly growing sector. We're very proud to be, we think our source is on I think nearly all of the platforms out there, and that's a community that we very passionately serve. We're moving a lot more into environmental monitoring. I think actually at the very beginning of the company, gas sensing and environmental monitoring was a big deal. It's now come full circle where we're actually looking at liquids and particulates in imaging that are coming from the oceans, for example. And then lastly, pharmaceutical. This is a big thrust for us, looking at drug discovery, vaccine development, using either the imaging or the liquid analyzer technology platform. And I won't go through all of the many applications. You can go to our website. We've tried to archive with good citation, the over 200 publications that are out there today that have been peer reviewed. But this is just a quick sampling of some of the applications that the Sparrow microscope and Kopeo analyzer are enabling today. Anything from semiconductor inspection to digital pathology with using the molecular fingerprint of the mid-infrared, to non-invasive glucose testing. I think we're going to see another presentation later this morning, which is really exciting, using quantum cascade lasers. So with that, I just kind of want to point out, there's many interesting emerging opportunities out there that we're seeing. We're thinking at this point, 5-10 years out. Typically, our forward operating planning cycle is every year, and we're always looking at least 5 years out of our investments. That's one of the advantages, being a part of Leonardo DRS, is that we are constantly, we're not looking for, next month kind of revenue. We're looking at kind of longer term opportunities. So we're always looking for innovative suppliers and partners to work with, who have kind of innovative building block capability. And I mentioned our thrust into liquid analysis. So one of the key areas for us is sample interface. So looking at very low cost, high volume, optofluidic type devices. I know EPIC is, quite involved in that area. So I would love to, to hear from folks if they got, solutions out there. We're very interested. So with that, my email address is there. Please feel free to contact me after the show, or I'd be happy to take some questions right now.
Thank you very much, Jeremy. It is 3:46 in the Netherlands right now. What time is it over there?
Well, it's 6:46.
6:46 in the morning. With a coffee in my hand, I'm going to ask you the epic question. We have 670 companies here. What can you do for them, and what can they do for you? What kind of cooperations can we start today?
Well, I think I tried to mention them at the very end, is looking for devices that bring the sample to the infrared light. That's an area that we're investing in significantly, but I think there's a lot of great innovation out there. That's one place I think we would start.
Jeremy, it's not really February if there is no Photonics West and I cannot go to your booth and we cannot have a chat about your new products. I really miss seeing you. But we have a question in the chat from a potential partner for you. It's from ST Microelectronics. Eric, what's on your mind?
Yes, thanks, Jose. Just can you comment, especially on your last slide regarding volume application and miniaturization? Which type of application you think could be, let's say, driven this trend of miniaturization? I guess you are in contact with final application providers.
Yeah, thanks for that question. I think one of the key applications that we're looking at is biopharmaceutical process monitoring, where sterilization is an issue. So if you want to be able to make measurements and then toss the sample, that's an application that would be of significant interest to us in the near term.
And you think there will be volume, because biopharmaceutical is not a niche, but is quite a limited market, no?
Yeah. So again, we're not talking about millions, but I would think we would be talking about tens of thousands.
Okay.
Per year.
Thank you very much. And I think there is obviously room for cooperation here. My friend Slava has the hand up. Slava.
Just one question, great presentation. We knew companies since that time when we visited Bell Labs, 20 years ago, and suggested to use infrared fiber optics in coupling with QCL. Question, all the examples you show, very nice products, they are always used when you should bring sample into the device. So question, in general, when you are really progressing in so many applications now, and we measured excellent coupling efficiency, it's more than 90% between, let's say, QCL and fiber. 50 times better than any FTIR spectrometer, you know. So then we can really have a chance to make kind of spider system which sits with your quantum cascade laser, not one laser, probably several lasers. With nanoplus today, we have 7 in one box, you know. So that's why we can really help to reach much more critical points, which is impossible to bring to spectrometer. You should really, you can go in pipe, you can go in exhaust pipe, you can go in aggressive liquid reaction. What else? Do we have an area to work together?
I do actually, and you know, again, along the same lines, you know, process monitoring is very, that's a great application for having an online probe that's kind of an attenuated total reflectance kind of thing. What we've seen as a challenge up to this point is it's not so much the coupling efficiency, but it's the spectral fidelity due to you know, small changes, you know, in bend radius could be creating some kind of you know, interference type of noise contribution, and those things are not always easily predictable and eliminated. Those are all solvable. It's just up to this point they've been kind of technical barriers to make them kind of widely adoptable. But I'd love to work with you, you know, and talk offline. I mean, we've certainly made a lot of progress in the last 10 years since we, you know, we did a lot of work in that area.
There is obvious. You're looking for a partner to provide the fiber to pigtail your lasers. There is nobody better. But I also think that when it comes to the lasers, for many of the applications you actually position, beam shaping is key. So we have an EPIC member, Cailabs from France. Tangi, you're here with us, and I want you to explore what can we do in beam shaping in mid-infrared and see how we can make a matching here with daylight solutions.
Yes, thank you very much, Anna and Jose, for this opportunity to present our solutions. At Cailabs, thanks to our MPLC technology, we are expert in beam shaping solution, and we have a lot of application around that, some of them in the mid-infrared range. Our proposal is to meet the power need in this range by proposing passive QCL combiners. Indeed, the QCL sources today are the most portable ones in the mid-infrared range, but the power is now limited to 1 to 2 watts for 4 micrometers, for example. And the Cailabs combiners allow, by combining several QCL at the input, to propose higher powers up to 10 watts with an optimal output beam quality, which is a risk with in-current combination. Our expertise in terms of fiber allows us to go up to the coupling of QCLs into the fibers and to propose at the end of our combiners also a specific shaping, as you said, Jose, at the output over long distances. For example, a topaz between 200 meters up to several kilometers. And the application, of course, are, for example, countermeasure, LiDAR, or laser communications. And if you are interested, feel free to contact us. If you want to know more, we would be very happy to find collaboration thanks to this wonderful event.
It is quite spectacular what you can do in any wavelength. And I think for the QCL companies, we already heard from Daylight, we're going to hear from MirSense later, from Nanoplus, from Alplacer. You can really make some critical operations. Thank you very much. And we have the hand up of EV Group. Martin, what's on your mind?
Hello, I have a question regarding the quantum cascade laser. What I'm wondering is, if I remember correctly, the main cost issue about quantum cascade laser is the epitaxy. However, I remember there was also some quite nice work of the University of Vienna to show that you can double the cascades by wafer bonding. Did you ever look into that topic?
So the question is the epitaxy cost a limiting factor in the cost of the final product when it comes to QCLs? Jeremy? Is the wafer, the epitaxy cost a limiting factor when it comes to the final cost of the package QCL?
It's certainly one of the drivers today for sure, but if you look at the overall system cost, it's not the only thing that's driving the end user price these days.
I basically, I am very naive. I always think this is a piece of semiconductor with the right volumes. IQE is going to make so many wafers, right? Ivan Davis from IQE, you're going to make so many wafers. It's going to be super cheap. We just need the volume to be there. Thank you very much, Jeremy. I can't wait to see you. I can't wait until maybe next year, Photonics West. Thank you very much. Let's continue with the next speaker. I want to go to Germany. And I want to go to nanoplus, any laser at any wavelength. I just love them. Thank you very much, Johannes, for being with us. The floor and the attention of everyone goes to the semiconductor lasers of nanoplus. You know what is the sentence of EPIC 2020? You are muted.
Yeah, okay. Now you can hear me?
Yes, loud and clear.
Okay, perfect. Thank you very much.
Let's go to presentation mode in your slides so we can see them.
Yeah, you have presentation mode? Okay. So, Jose, thank you very much for the introduction. I have news for you, several news. You always talked about nanoplus and lasers. Perfectly right, definitely. But there's more to come. So this is one part where I have news. The other part where I have news, you see two companies up there. One is nanoplus, the other is called Sensorlight Technologies. So both companies, I'm involved as a CEO. And partly owner, but there's a difference between the two of them in the regard which markets they address. So nanoplus is definitely for the high challenge market with low volume spectroscopy markets up to 10,000, 100,000 pieces. And Sensorlight now takes these technologies we have developed inside nanoplus or partly inside Sensorlight Technologies, and push this into the markets of 1 million, 5 million, 10 million devices. So this is a basic differentiation between these two companies. Nanoplus focusing on low volume, high quality, high challenge semiconductor devices. Sensorlight is looking into mass markets. And so we try really to push this technology, this mid-infrared technology, further into broader applications. This is the idea behind it. So this is the first news, but there's more to come. First of all, one unique point about nanoplus is that we are fully vertically integrated. This is something which is, I think, quite unique. So we do material design, we do the simulation, but we also do the whole epitaxy. We have 3 MWIR systems running here at nanoplus for gallium nitride, for interband cascade lasers, for QCLs. We do also the whole device processing in-house. We have also device mounting, we have the characterization, we have the burn-in, we have the qualification, everything is here in-house. And this allows us to have a fast turnover of technologies. So if you need something special, something new, a new package, a new semiconductor device, we have everything in our hands really to help you and to develop devices for you, develop new packages for you, whatever you need. Coming to our product portfolio, at the moment we have 5 product pillars, I would say. We have the DFB lasers, we have the Fabry Pro lasers, we have the SLDs, we have the mid-infrared LEDs, and more customer packaging, collimation, technology development, lithography service, everything you need to develop new devices, new packages, and to access new markets. And this is an exciting point about it. So first of all, our DFB lasers. I think this is the part where we are most famous at the moment. So we have the 3 different technologies inside this. We have diode lasers, we have interband cascade lasers, we have quantum cascade lasers. So we cover 3 different semiconductor-based technologies to provide different wavelengths. So diode lasers from 760 nanometers up to 2.9 micron, interband cascade lasers from 2.8 up to 6.5 micron, and the QCLs, from 6 to 14 micron at the upper end. They all have large tuning coefficients, they have high powers, and you can really get the laser, as Jose pointed out, at every wavelength. So you name us your wavelengths, we provide those wavelengths. Whatever you need, we can make it for you. We have also the various options for packaging with fiber, with TC, with NTC, with all the stuff you need. And we can suit your application, hopefully right perfectly. Then we have the Fabry Pro laser diodes. We can cover the whole range of our technologies, diode lasers, interband cascade lasers, quantum cascade lasers, and we provide up to 1 watt, sometimes even a little more, above 1 watt for different applications. For example, at 4 point something micron for countermeasure, 9 micron. These are the typical wavelengths for this, but also for medical applications. We have one partner in EPIC where we address these kind of applications. So there are many different applications out there which we can go for. And this is quite unique, quite new, that we offer this high power lasers also with our base technologies we always had in-house, but now also with high power for these special applications. And I think there's much to come in this, especially in the medical field. There's a huge benefit for laser technologies. Tattoo removal, for example. I'm quite sure that tattoo removal is done by some arbitrary wavelengths, but not by the perfect one. And I think we can provide the laser for this. Then we have the SLDs. Yeah, sometimes, as Keith pointed out from Philips, you don't want to have the whole coherence. So we have superluminescent diodes starting from 760 nanometer going up to 2.9 micron. They have comparable high power, 10 milliwatts of output power. They are broadband, again, customer specific. You name us your wavelength, we will send it to you. They have a small footprint, and yeah, we have also various packages for this. So we can provide any kind of package for you which suits your application. And also very new, mid-infrared LEDs. Up to now, most mid-infrared LEDs were kind of lame pulsed emitters, which only very low output power. We now have true CW operation at room temperature, covering the range again, 2.8 micron up to 6.5 micron. We have more than 1 milliwatt of output power. So again, if you fear coherence, then perhaps the mid-infrared LED is your choice. Yep. So this is the overview about our products, and now I'm happily open for your questions. What we are searching for are partners which develop together with us new markets. So with nanoplus, markets in the volume 5,000, 10,000, 100,000, and with sensor light markets 1 million, 2 million, 5 million, 10 million. So this is what we are searching for here in EPIC. Thank you very much for your attention.
Thank you very much, Johannes. Very nice presentation. And what kind, I mean, regarding these markets, no, in which you want to go to larger volumes, what kind of markets? What is the market that you think that you are going to reach these volumes first?
So for the high volume markets, there are several markets. Carbon dioxide is something, how to say, there are many players out, but there are further markets, like Keith mentioned in the healthcare, medical environment, fitness monitoring, for example. We can provide lasers and SLDs, which are perfectly suited for monitoring the lactate level in blood. I think this could be something exciting if you have a fitness watch measuring your lactate level. Or we can go glucose and old stuff, but we also go to alcohol, for example. We have one product where we measure alcohol in human blood together with partners. So there are many applications out there. We are just scratching the surfaces with infrared. I'm absolutely convinced of this.
And Johannes, which are the partners that you could be looking for to go to these larger volumes? And I mean partners in the supply chain. Are you looking for something special?
Well, we are looking at both ends. So, for example, micro optics definitely is something we need for high volume, low cost applications. But on the other hand, we search for partners like ST Microelectronics going into large volume applications, like Philips going into large volume and mid volume applications. And around the whole chain, more or less, we need an ASIC, for example. Okay, perhaps not in EPIC, but we need partners along the chain. And I'm quite sure a lot of them we will find in EPIC, absolutely convinced. We have good contacts here in EPIC already. And I'm quite sure we will find more.
Very good, Johannes. Okay, so we have some questions, okay, in the chat. So first of all, Indra from BU University. Do you want to make the question by yourself?
Yeah, sure. Thank you so much. I'm working in the OCT imaging side. I'm a researcher, not a company.
Hi.
Okay. Yeah, I was wondering if you have any researchers or any companies working in the field in OCT imaging doing mid-IR, because it's not very common. And I was wondering, because I'm also willing to get into this field myself. You probably remember Bob van Somera. He used to work with you. He's my collaborator now. We're working very much together. Yeah.
Okay. Smart guy.
That's why indeed I was thinking, if it's this is our dream, huh? We want to make an OCT system working in the mid-IR range. Yeah.
So perfect. Something I haven't showed, which is in research phase, still our broadly tunable lasers. I think they should be perfect for OCT.
Yes.
And we are
very nice.
Yeah, we're transferring this technology to the mid-infrared at the moment. And I think for research projects, this is a perfect timing now, perfect point in time where we can start working on topics like this. Broadly tunable lasers in the mid-infrared for OCT applications.
Okay.
Would be very exciting, because I think this is also an interesting market in the end.
Yeah, indeed. Yeah.
And the science is interesting.
Yeah, thank you so much. Thank you.
Yeah.
It is an interesting market. Okay, next question. Ian from Vortex. Do you want to make the question by yourself? And maybe do you have a slide to show the capabilities of your company?
Yeah, sure. The question for Johannes was, in your presentation there was quite a lot of broadband sources. How do you tune them down for specific applications that people come to you with?
So that's a good question. Thank you for this, Anne. So one thing we can always do, because we have everything here in-house, we can influence the epitaxial structure. And with the epitaxial structure, we can put mirrors, Bragg mirrors on top of it and below the LED, for example. And with this, we have a measure to tune the spectral emission a little bit. Furthermore, we have also quantum mechanics effects where we can per se tune the gain, the width of the gain in these semiconductor devices. Yeah, so these are the two main possibilities to have an impact on the width of the emission from the e-inquiry devices.
Yeah. Is it also possible to use an optical filter to do it, if you're looking to isolate a particular narrowband?
If you want to isolate a narrowband, it's also an option, definitely.
Yeah, okay.
Ian, do you want to show your slide now?
Yes, I can do. If I can share my screen. Is that okay?
Yes, it's okay.
Okay. So, I mean, a quick sort of recap of some of the things that have already been mentioned. I mean, why are people doing stuff in the mid-IR? And, you know, people are moving out the visible now and looking at it with some serious interest, because there's some strong features there that aren't apparent in the visible. And looking around the audience, there are better offerings in terms of components right across the board. Prices are coming down as well. And the mid-infrared could be the answer to some of these world problems that we're all trying to deal with, including things like plastics recycling, more efficient agriculture, using disease biomarkers or detecting disease biomarkers, and also environmental monitoring as well. So a brief sort of what an optical filter company can do for you. There's a few things. I mean, us in particular, we've got a lot of experience with applications, so we have great advice for a start, but we're also able to design and manufacture filters, any sort, narrow bands, wide bands, dichroics for splitting off different channels or different parts of light. We also make linear variable filters as well. So if you're looking to make a mini spectrometer, that could be a key component in that. And then good old anti-reflection coatings as well. And, you know, we're the type of company who are able to make rapid prototypes at reasonable cost. And that's a few examples there of what we can produce together with my contact details. So if there's anyone out there, I would be delighted to speak to you, maybe offline afterwards.
Okay, thank you very much, Ian, for this small presentation. Now we have another question in the chat. So regarding your needs for micro-optics, Johannes, Wilfried.
Thank you, Anna, again. Yes, of course, I have a question. You mentioned nanoplus mentioned the micro-optics. So we make micro-optics. We make it in glass, but also in silicon. We use intrinsic silicon, so we actually did an FTIR measurement and could show that we have a very high transmission in the mid-infrared. And the question is if this is something of interest for you. So we also help you with the optical design if need be. You said you have a lot of design capabilities in-house, but we can also design it. We can do beam shaping, we can do diffractive optics, we can do collimation optics, and you name it. And we could probably do that in silicon for you, for your wavelengths that you mentioned. We can work up to 12 microns with our silicon lenses. So maybe not 14, we have to check, but 12 should work.
Oh, perfect. This is something we are definitely needing. We are searching for this, but we're already a customer. You know, yeah, it quite well.
I think I see. I'm from the R&D. As everything that goes through our standard channels, I don't see anymore. This is my problem.
Yeah,
so.
Perfect. But we have you on the radar. We know where we look for micro optics.
Okay.
But thank you very much.
Great. Thank you. But we offer more than just lenses, huh? So this is what I'm.
I know.
So,
I know.
Yeah. Okay. Good. Thank you very much. Sorry, very embarrassing.
No, not at all.
One of the things that we need to look at is in the future, we really need to couple different beams into one single mode fiber. And for that, the micro-optics arrays are actually going to play a huge role. And also the micro-optics for the packaging of the quantum scale lasers into silicon photonics and other planar structures is the future. There is a huge boom of micro-optics in Europe. Johannes, I'm really happy that you're working with Cees, and we had the whole micro-optics revolution behind them. And also we have a really good set of companies developing the filters that we had from Daylight requesting, and also, of course, from Johannes. Do we have somebody from Optics Balcers in the room?
Yes, Jose.
Reto, of course.
Yeah.
So in the business of mid-infrared, I know that Optics Balcers has had a couple of very good years developing filters for many different application fields. In the business of mid-infrared, what do you do? I heard from Anna that you actually do have a slide.
Yes, I would share it if that's okay.
Please do.
Just a second.
I cannot hide how much I like Optics Balcers. And this is horrible not to be able to travel. We should all go for dinner now and have a beer together.
Yeah.
You should be able to see my slide now. Is that correct?
Crystal clear.
Okay. So you mentioned Optics Balcers in the infrared. Maybe I have to correct that slightly. Optics Balcer traditionally is very strong in the wavelengths from ultraviolet to maybe to shortwave infrared. That has been the story until mid of last year, and then we were acquired by the company Materion. We're now part of a much larger global operation, and Materion's focus is really on the mid-infrared and on the long infrared. So there they have a comprehensive portfolio of solutions for gas sensing, and they're very strong in particular in medical gas sensing, what you heard before a couple of times. Their key differentiators really to make the very accurate filters that are used, for example, in capnography, medical capnography, and also anesthetical gases. So Materion is very strong there, and certainly also in the long wave. But that maybe that is a bit restricted to European customers due to export control. But just to mention another thing where we also, where I'm personally excited about is really the combination of some of the competences, because Materion also has a large packaging, microelectronic packaging solution in-house. So everything about hermetic packaging and in combination with optical filters in the mid-infrared and also in the long infrared, where Materion also has their own IP for getters in order to get rid of some of the molecules inside of a hermetic package. There, I think Materion has really a strong offering, and I would be happy to connect anyone who's interested to looking for solution in that area.
Okay, thank you very much for this short presentation. So now we have another question in the chat. Yes, Gernot from Scott. Would
yes,
you like
hello.
to yourself? Hello.
Yes, I have a question. It's a general question, and all we, as SCHOTT, as you know, are a material supplier, and right now we are really focusing in IR materials, and we introduced our chalcogenide classes, our IRG classes, to the market. And one general question here for the community would be, how are you interested, or what is the base material you are going to use, and do you have any special needs we can fulfill here? And if there's any need when it comes to IR materials in chalcogenide, zinc sulfide, or sapphire, we are really happy to support you in any kind. And when fiber, we are doing fibers too, as you know, from SCHOTT. So the question is, and I put it in the comment box here, what are normally the basic materials which are used for your mid-wave application?
The question is, of course, for all the companies who are developing components in the mid-infrared. So I'm gonna point my finger to Cees Micro-Optics, Wilfred Neal. Wilfred, you said today that you have micro lenses that go all the way to 12 micrometers. And of course, I know that you actually use nano-imprint lithography and replication to make your micro-optics. When it comes to the polymer, to the material, they are looking for partnerships. Is there any particular request for a material with different refractive index or different molded solutions?
So yes, so micro-optics, imprinted micro-optics, we work mostly in the visible, but we also like to go to other wavelengths, of course. This is very interesting, especially when I see all the sensing applications today. If we could do that with imprint, that would be super cool. And so we look always for high index materials and materials that can be cured very quickly. So the current materials that we use, they're great, but the curing time is sometimes a bottleneck for some applications. And so this is maybe so high index, short curing times, low shrinkage. This is the holy grail of polymer development. And if anybody can offer this, then we have big open ears for that.
Thank you very much, Wilfred. Thank you, Gernot. And let's go to the next speaker. Let's go to Thorlabs. Thorlabs. Oh my God, Thorlabs. Thank you very much, Reza, for being with us today. The floor and the attention of everyone goes to the best candy maker, t-shirt maker, and of course, photonic component maker that we have in the EPIC network goes to you.
Okay, thank you very much. Yeah, I'll be talking a little bit today about the broadband mid-IR sources.
All right. Yeah.
Can you hear me well? Okay. Yeah, so I'll be talking about broadband mid-IR sources. We offer a broad range of different mid-IR products, but today I'll be focusing mostly on our laser business. So to motivate that topic a little bit, I think we heard a little bit about different applications today, and really comes down to specific applications for the lasers where you would need different varieties of broadband sources. So what's available today in the traditional FTIR systems for decades, you've seen thermal sources, which are basically lamps and glow bars. These are particularly attractive because they're compact and low cost, but obviously they suffer from lack of spatial coherence. You can kind of see that in these two images of collimated glow bar and collimated lamp. You could see that the beam looks completely distorted. So this works okay for a lot of applications, but there are certain applications where you would need this spatial coherence and high brightness. And the solution that a lot of people, at least in the research community, have been looking for and have used is the synchrotron facilities that offer, an infrared beam line with spatial coherence and with orders of magnitude, typically 2 to 3 orders of magnitude better brightness compared to thermal sources. Obviously, this is not a good solution for the market because of the high cost of operation, plus the fact that synchrotrons are not portable systems. So you would have to bring experiments and systems into facilities to actually get some use out of them. So what we're talking today a little bit about is sort of emerging laser solutions to this problem. which provide the spatial coherence, high brightness, but they're actually portable, they're benchtop, or even integrated photonic systems that can go into handheld devices and things like that. So in that arena, we're talking a little bit about fiber-based systems, supercontinuum in particular, and quantum cascade lasers, which are semiconductor-based. And they both offer good spatial beam quality, orders of magnitude higher brightness than thermal sources. In fact, in some cases, better than synchrotrons. And they can even be fiber delivered. So a little bit about supercontinuum. Really, the concept here is that you start from a pulse propagating in a nonlinear waveguide, and that pulse, as it propagates in the nonlinear waveguide, essentially it broadens its bandwidth to octaves of bandwidth at the end of the waveguide. And this gives you a broadband source, but it's also generated in a single mode waveguide, so it has the spatial beam qualities that we're looking for, and it's very bright because it could have watts of power level. What we're doing with this concept is shown here in the design diagram in the top of the slide. We start from a femtosecond fiber laser at 2 micron, and we chose specifically the femtosecond regime to minimize spectral noise. And then we couple that into a fluoride fiber, which is grown and developed in-house, both in terms of material and fiber draw. And these materials are, I think I mentioned a little bit earlier in this meeting today, that they transmit out to 5.5 micron. So you could really utilize a big portion of the mid-infrared out to 5.5 micron by using this type of fiber. And these fibers can be coupled directly to the fiber laser. So it provides an all-fiber solution that could be robust and compact. So what I just talked about, we released that as a product a couple years ago. It's called SC4500. It's a benchtop laser, and it covers 1.3 to 4.5 micron with more than 300 milliwatt of average power. We also get really good noise properties, which is really driven by the fact that it's a femtosecond architecture. Here I've shown sort of a sample output spectrum and also a beam shape. So you can see that these are really good M square of 1.1 or something around that vicinity. And you can get very circular beams as well, because these are generated in single mode round fibers. So going beyond the supercontinuum, there are other options available in terms of broadband sources too. And I want to specifically talk about quantum cascade lasers. So quantum cascade lasers are known to produce a lot of power. You can get more than a watt of power out of a QCL chip. It also provides a fairly nice single mode beam quality because these waveguides are also single mode waveguides. What's interesting about what I'm presenting here is that because the wavelength of the QCL is not determined by the material composition, but it's determined by the material thickness, the structure thickness in the device. You could actually imagine cascading different thickness layers within one chip and broaden the spectrum of the QCL. So here in this plot, you can kind of see one example. We have a device that lasers around 10 micron, but you could actually design it to have a bandwidth that's 1.5 micron, around 10 micron. So now we have a broadband source, maybe not quite as broad as a supercontinuum, but something that can be used in a spectroscopy application. And you could also imagine putting 3 of these devices side by side, still within a very small footprint, and get even a broader bandwidth source. And finally, there's you can take this one step further with QCLs. This is very new, and a lot of research is being done in this topic, but it's not really hasn't been incorporated into a product yet. But you could actually make these QCLs broad, but also phase locked, in the sense that the different Fabry-Perot comb lines are locked together. And this is achieved by certain design of the chip in terms of nonlinearity and dispersion. But if you do that, you actually get the frequency comb, which is beyond just the broadband source. The phase locking capability between the comb lines actually allows you to do dual comb spectroscopy, for example. So the advantage of that really is that you can go beyond FTIR and actually do these spectroscopy measurements using a single photodiode and an RF spectrum analyzer. So this provides a path for faster measurements, more portable and simpler measurements as well. So just to kind of summarize and talk about partnership opportunities, really what I wanted to tell you today was in terms of broadband mid-IR lasers, we have a fairly broad portfolio. We do fiber-based, which is super continuum, and we do semiconductor-based, which is quantum cascade lasers. And we're very vertically integrated in both areas. We do everything from material development all the way to system integration. Where we see opportunity for collaboration, and I'd like to explore that with already with a few of the speakers today, is new spectroscopy applications where these kind of broadband lasers with high spatial coherence can really provide the advantage that we're looking for compared to thermal sources. And I listed a few of those example applications here. For example, open path analyzers, these require really long range transmission. So obviously that could benefit from these type of spatial coherence sources. There is hyperspectral infrared microscopy and near field imaging that was also mentioned today. Those are another area where you can really use a diffraction limited spot size from a laser. And also as in addition to that, dual comb spectroscopy. And here what we can also offer is optimizing lasers in terms of both material and device, and also in terms of optimizing the system level to specific specs or footprint or architecture. So we're looking for opportunities to kind of work together with other companies out there to bring some of these lasers into the application world. Thank you.
Okay, thank you very much, Reta. Very interesting presentation. I mean, and in order to have clear what are the collaborations that are you proposing here, maybe you can highlight one of the challenges that you are presenting here to the supply chain.
Yeah, so I think really the challenge here is that a lot of these technologies we talked about, and you know there are other technologies today too. For example, the LED that was mentioned by nanoplus. These broadband sources are so new to the market that I think a lot of the traditional applications, for example, the mid-IR microscopes and hyperspectral imaging and things like that, they haven't really been explored with the right laser. So we can really work with a company that's doing the application side of things. They're looking at spectroscopy, they're looking at detecting materials or things like that to really demonstrate that you can get orders of magnitude improvement. And really the challenge is that lasers come at a high price tag compared to traditional sources. So unless there is orders of magnitude improvement in performance, it gets really difficult to bring them into the real world. So those are really the areas of focus that we're looking at.
Thank you very much, Reta. So maybe we have now here the right company for you to have a collaboration. We have also a comment here in the chat. So Bertrand from Chromacity. Do you think it's a good moment now to introduce the capabilities of your company?
Yes, I did. I think it's the right moment for us to present. So let me just share my screen with you all.
Okay, if you can go to the other screen. Okay, yes.
Here we go. You should see it now.
Yes,
well,
yes.
Thank you very much, Anna, for giving me the opportunity to jump now in the presentation. Hello, everyone. In case you don't know Chromacity first, we are a Scottish manufacturer of ultrafast lasers. And in relation to the topic of the webinar today, our product range includes two systems that span the mid-infrared. Both these products are picosecond optical parametric oscillators, as you can see in the center of this slide. So one of our OPO covers exclusively mid-infrared wavelengths from 4.5 microns to up to 12 microns. It has a great potential for defense and environmental applications, allowing in particular multi-species gas sensing and monitoring, thanks to its broadband nature. Our second OPO, identified commercially as the near-infrared OPO, covers effectively the near and mid-infrared wavelengths spanning up to 4 microns. Applications for this product in the mid-IR have proven to be varied. Firstly, standoff detections of fugitive gas emission at distances up to 200 meters, thanks to its high brightness and broad bandwidth. In addition, quantum optics experiments have been conducted to generate 2 photons entanglement at longer wavelength compared to the more traditional near-infrared spectral window. The compactness of these OPOs, including their integrated pump source, makes them suitable for both research and industrial applications. They are also affordable when considering their broadband nature and the high average power delivered. And last but not least, we have the capability to remote install our OPOs, this demonstrating the robustness of their design and their stability. So this is what we offer at Chromacity. I think it was a good moment to present following the presentation of the supercontinuum and the QCL. And we're obviously looking at expanding the use of our OPOs to more applications with both the research and the industrial communities. So don't hesitate to come back to be in touch with us now or later. And by the way, we will be also exhibiting during the Photonic Plus event later this month. Thank you very much.
Sorry, thank you very much, Bertrand. Very interesting slide. So, okay, so if there are no more questions or comments, we can move to the next speaker. So, Mathieu from MWIR. Would you like to share your screen and start the presentation?
Yes, I share my screen. Okay, can you see my screen?
Yes, very good.
Okay, thank you. So I will present to you MWIR and especially news we have in MWIR because the company is it's not so old because now we are 5 years old, but but we've decided to innovate quite a lot in the field of mid-infrared. In fact, in the field of lasers, as you will see, because we do quantum cascade lasers solutions and sensors based on quantum cascade lasers, because we wanted to solve this issue is that having a laser is a good, I would say, solution, but it's also a big problem. So we do, I would say, a solution based on quantum cascade lasers, and our philosophy is to help the customer to use the QCL or to use the sensor based on the QCL. So, oh, sorry. Doesn't work, okay. So I will present first our product portfolio. So our QCL product, high power QCL and DFB QCLs. Then I will go to the gas sensors. So basically we have industrial gas sensors and we have also sensor chips. And as it was mentioned before, we have also split this market in 2 different product lines. Multisense is for industrial high value, high-end markets, and MWIR chip is for large volume applications, basically above 100,000 million units. Okay, so first of all, I will talk about UniMWIR. So this is kind of a big news this year, is that we've just started a new product line, and this product line is meant to be changing a little bit the mid-infrared world in the sense that we bring new wavelength range in the field, 10 to 17 microns, and even up to 25 micron in pulse operation. So this is a new QCL technology. And so that means that before we were stuck to, let's say, up to 12 microns, basically, with, I would say, high performance room temperature operation. And now we bring this wavelength to a new range, going up to 17 micron in continuous wave and up to 25 micron in pulse operation. So that means that new wavelength range with new bands, in particular, for instance, benzene, UF6, toluene, some of these molecules, they can be detected very well in this wavelength range, and you could not before. So if anybody is interested in having sources with the same quality as a standard QCL, that means a few milliwatts of continuous wave operation, room temperature operation in the standard HHL package with a standard 25 dB, 30 dB SMSR, depending on the application. And of course, as you see, this is quite a, it's not usual to see numbers below 1,000, that's for sure, but this is a 627 centimeters -1 laser. And it can be tuned for a few centimeters -1. And of course, you get the line width of a continuous wave lasers, and it's TM00, and typically the beam size is 4 millimeter. So we are looking for customers interested in such a product to build new systems for new molecules. Of course, I want to mention that we are very active in the field of high power laser. This is the PowerMIR product line, where we deliver higher than 1 watt product at 4 micron, 4.6, 9 micron. Typical beam divergence are in the 2 to 3 milliarad in the both direction. And we've developed recently a circular beam technology. That means that for integration of the lasers, it's much more easy to have a totally circular beam. This is the M square is very close to 1, and the beam has the same divergence in both directions. It's totally Gaussian. And also to help people to integrate more lasers, we have developed softwares and firmwares and platform for people to be able to drive simultaneously more than 1 lasers. So here you see, for instance, 5 lasers driven by a unique controller on this PC. Okay, so we are ready for, of course, high power single diode applications, but also multi-diode. By the way, we do work with some of you already on increasing the power of the sources by combining several lasers. Now, as I said, giving a laser is good, but it's also giving problems. So we said we should not give only a laser to the customer, but give a solution. And the solution is directly gives them a molecule concentration, for instance, in ppm. So we've been developing a portfolio of gas sensors. This is a 4 QCL gas sensor. It's basically about 8 by 8 centimeters by 15 centimeters. So it's less than 1 liter. And it's sub ppm. So LOD of these sensors is typically below 100 ppb. So you can detect simultaneously up to 4 gases. So application goes from industrial application, environment, air emissions, and industry, as you can imagine. This is right now available. This is an OEM product. So here we are looking for integrators to take this technology to the field, to application. So we have already some gas sensors in customer equipment, in process control, in environment monitoring, emission control, in gas purity monitoring as well. And so it's available, and it's I would say it's field proof. But of course, this, as you can see, cannot go to the million volume unit as it is quite big, and it's a high, I would say, high-end product. So we've been developing another product line. This is a totally new sensor that we've developed, and inside this sensor you have, let's say, right now 2 to 5 QCL, and this is the size of a sugar cube, as you can see. And inside you get photoacoustic sensors with, as I said, up to 5 lasers. So it's also available for gas sensing. So it's at the proof of concept level, because of course, for each application, this has to be fine-tuned to reach the performance and the cost. So we are looking for partners as well to integrate such small sensors and reach the large volume markets. Can be used in health monitoring, in environment control, in emission control. Of course, can be used in automotive, can be used in bio application. So we are available, and for that also we are interested in having some partners in EPICS providing components. So whether it's coatings, micro optics, but also a component dedicated to electronics that would suit our requirements. So please feel free to contact us, because we are targeting a numerous applications for large volume markets. Thank you.
Thank you so much. First of all, it is amazing that you managed to have the platform from 10 to 17 micrometers. This is huge, and my fingers are crossed for this Prism Award. Also, of course, for Thorlabs and for Light. I hope the EPIC members win. But also, I think it is amazing what you've done in the last years, making a difference for the output power of the QCL, having a limiting factor for many applications. Quite outstanding. I know what you can do for each other, so let's go directly to the questions. We have a question in the room from Ian Reilly from Vortex. What's on your mind?
Just unmute myself. The question for Mathieu is how do you tune the broadband source for the particular materials? You mentioned benzene in there and probably other materials as well.
Okay, so in the case of our new product line, in fact, we changed the material the material system. So we've been moving from indium phosphide based material to antimonide based. So, and by doing that, we changed the quantum well depth. So we have access to different quantum well depths, and also we can access longer wavelengths because we increase the gain. And by changing the gain parameter, we can go much further in wavelengths. And also one last point is that we don't have some phonon effect that we do have on indium phosphide that disappear and usually absorb around 15, 20 micron, and we're preventing this technology to reach this wavelength range. So it's a couple of different things. And now we have this technology that works room temperature continuous wave.
We have an anonymous question in the room. Are you using single pixels only, or are you also interested in MWIR and LWIR imagers?
I would say right now, basically, we focused our portfolio on photoacoustics. So the detection is done via MEMS microphones.
We have another question in the room from Reza from Thorlabs. What's on your mind?
Well, I was curious about the long wavelength QCL development. You mentioned you've reached up to 25 micron. I was wondering, first of all, what applications do you see for longer than 12 micron? Are there specific molecules or specific applications you're looking at? And also, are there reliable and low noise detectors available to even support 25 micron?
Yeah, so basically right now, concerning the applications, you have molecules that are typically specific band in a 15, 16, 17 microns. So it could be, like I said, BTEX have very strong line there. Could be also UF6. So you have different applications in critical domain like in a defense and nuclear industries. And okay, so that's where we find our niche right now. But of course, since it has not been looked a lot because the sources were not there, it's also a new field. So we should also give the possibility to people to test such laser. In term, you mentioned about the detectors for these lasers. So yeah, indeed, in terms of optical detector, there are some detectors up to 14, 15, but then it kind of get a little bit more complex. So that's why we also rely on photoacoustics on our side to be able to detect, because with photoacoustics, you don't care about the wavelengths, basically. You just care about the power you inject inside the molecules. So you can do architectures based on photoacoustics on one side, but of course, you can find also some sensors that go beyond in wavelengths, but maybe not in quantum detectors.
I'm very interested now about, oh, sorry, we have a question in the room from Slava from Art Photonics. What's on your mind?
Thank you for good presentation. You should make your stuff with 5 QCL or let's say 4 together, which you drive by the same driver, let's say. How do you combine power from different QCL at different wavelengths? Is it beam splitters, mirrors?
That's the beauty of photoacoustics, is that you don't need really to have high quality beam management. So basically, you just need to get the power in the same acoustic cavity.
And so it means parallel beams going through the same acoustic cavity?
Yes, basically.
Yeah.
But
if you have a spider who will simply combine power from all the, let's say, QCL.
No, of course. No, that could be interesting, and we are very interested in fiber providers, because what we do right now is basically limited to the fact that the emitters and the receptor are at the same position. If we want to split them and go to application when the receptor can be further away, that's very interesting to go to fibering. So now we have a strong interest in fibering our lasers. So of course we can talk about that separately, but we are very interested in right now having the right way to combine our lasers into fibers.
Mathieu, this meeting is not only for your suppliers, you've done a great job there, but also let's talk about the other side of your supply chain. I want to go to Huawei. And the reason why I want to go to Huawei now is because I just heard the most amazing story from Mirsense, and I want to understand from Huawei, what is your interest in mid-infrared? From that, we have Romain. Romain, thank you very much for being with us today. Tell us, what brought you to this meeting? What collaborations we can start?
Thank you, Jose, and thank you for the event. It's really interesting to see how the mid-IR is growing. In Huawei, at the moment, there are some interest on the highly transmissive IR materials that could be cheap and available on wafer. On wafer, like 3-inch wafers, basically. Can you hear me properly?
Yes, loud and clear.
Okay. So yeah, some interest on high transmissive IR materials. So we are looking for suppliers or experts in this domain.
Fantastic. I think you just made a lot of people in this room extremely happy. Let me remember, get in touch with each other now or send me an email. I will make the introduction. I would like to go now to the next speaker. And for this one, this is one of the champions that we have in the mid-infrared community. We are going to Spain. We're going to Rodrigo Linares Herrero. NIT, New Infrared Technologies, a company have made a huge difference on the MWIR cameras for laser material processing and also for the environmental monitoring and even space. Rodrigo, thank you very much. Muchas gracias for being with us today. The floor and the attention of everyone goes to NIT.
Well, thank you very much, Jose, for this kind introduction. Good afternoon, everyone. Let me share my screen now. Okay. So I would like to thank EPIC, of course, for giving us the opportunity to participate in this online meeting in MWIR Photonics. I would just like to start my presentation just with a brief introduction to NIT, New Infrared Technologies. We are a Spanish company supplying innovative mid-IR detectors, high-speed infrared cameras, and industrial solutions. So the detectors that we manufacture are based in PBSC. This is a very known material, but we process it using an innovative processing method, which is fully compatible with silicon CMOS wafers. So we are capable to obtain monolithic detectors with no need of hybridization. I think this is a key factor for something that has been mentioned in previous presentation, because this allows miniaturization of the sensor plus the proximity electronics, everything in the same chip. The performance of these detectors are quite unique because they have detection in the whole 1 to 5 microns band with a peak detection in 3.7. They have high-speed capabilities, and most important, they are capable to operate at room temperature with no need of cooling system. And this, of course, has a direct impact in the overall cost because there is no need to introduce complex cooling systems for operation. So the uncooled operation is quite important. You can see that we are a vertically integrated company. We cover all the steps from the detector concept to the final product. We participate in the detector and ROIC design. We process our sensors in 200 millimeter silicon CMOS wafers. That allows us to process hundreds of detectors in one single manufacturing batch. We have our own method for packaging. We design the proximity electronics. And in the end, we offer OEM models, industrial cameras, and final solutions for integration in production into the production line. So our products and solutions are targeted to integrators, solution developers, and end users. On the left side, you can see our products for sensors and cameras, and on the right side, our systems target to industrial solutions. So from the detector perspective, we can offer single pixels or linear arrays. Here you can see in a photo a linear array with a linear variable bandpass filter, which is turning the linear array into a multi-band device. So in this case, it's very convenient to be vertically integrated because we can customize our detectors to accomplish our customers' requirements. However, our current state of the art is the Tachyon 16K Camera Plus. This is based in a 128 by 128 pixel focal plane array with a pixel size of 50 microns and capable to achieve a frame rate of 4,000 frames per second in a snapshot mode at full frame resolution. It's also capable to go at higher frame rates if you narrow the window of acquisition. The camera has an industrial envelope and it has a GIG vision interface, is powered over the Ethernet, etc. One of our main focus in the mid-IR market is, of course, the industrial solutions. In this case, we have two systems called CLAMIR and i3MS, which are embedded systems that can operate in a standalone mode with no need of a permanent connection to the PC, allowing integration in the direct integration into the production line as a quality assurance system. So, for example, CLAMIR is designed for quality assurance of a laser directed energy deposition process. This is a 3D printing or a laser cladding, everything with metal. This system is integrated directly into the laser optics and performs a real-time monitoring of the melt pool width and controls the laser power in real time. This allows to improve the efficiency and repeatability of the process, avoiding downtime production stops. So, CLAMIR, this system was awarded in 2018 by the European Commission with the Innovation Radar Prize in the category Industrial and Enabling Technology. In the case of I3MS, this is a system that is designed to monitor the melt pool width and generate an analog output proportional to that width. And the user can use this signal as an input to a control system for their control of their production machine. So both systems are supplied with software that we also develop. And this allows data logging and analysis of all the parameters of the process. But we also provide a library to ensure the full integration into industrial equipment, so that the manufacturers of industrial machines, they can integrate our solutions directly into their platform developed for the human-machine interface. Just these are some of the applications where our main customers are using our mid-IR cameras and solutions. Starting with the quality assurance of laser-based processes, as I mentioned before, laser-directed energy deposition and 3D metal printing and laser cladding, process monitoring and control, or laser welding. This we have developed a product that combines the camera with a machine learning system, AI, that detects defects in real time during laser welding processes, or other 3D printing techniques like SLM with laser, or WAM with arc welding, for example. Another application could be in the quality assurance of glass manufacturing of glass bottles. In this case, the mid-IR is important because the bottles are not transparent in these wavelengths. But some other application is spectroscopy and a very novel technique of hyperspectral imaging called dual comp that allows molecular fingerprint imaging. And I would also like to mention the strong collaboration that we have with the industry through H2020 projects for many of these applications that I just mentioned. One of these projects, FLARE, just finished and was focused on the development of a portable spectroscopy device for bidimensional 2D mid-IR spectroscopy that allows detection of several gases simultaneously. So with this, I finish this very quick overview of our products and applications, everything related to mid-IR. That's the field where we are focused. And I hope that you have found this interesting. So thank you very much for your attention.
Thank you very much, Rodrigo. Very interesting presentation. Can you think about a challenge in the supply chain that you would like to share here with the companies in the room?
Well, as I said, as we are vertically integrated, we always have challenges in putting all the components together into a single device. So I think everybody, we like to cooperate very well, very much with our supply chains. We are always looking for packaging solutions, filters, silicon windows, or with specific coatings or specific filters. I think those are the main challenges that we are focusing when we manufacture our detectors, of course.
Thank you very much, Rodrigo, for this. And I think very linked, one of your collaborators, I would like to introduce now one of your collaborators, Laurent from CSEM.
Yes, I'll just share my screen.
No. Yes, please. I think you want to show us something, right?
Yes, just some results on the FLARE project. I think you can see my screen.
Yes.
Okay, so as Rodrigo said, so we collaborated on the FLARE project. It's a H2020 project. The goal there was to make a portable spectrometer that could fit on a drone or on a helicopter. We have several partners, but NIT was one of the key partners in providing the camera. You can see it here, which was a detector for our system. At first, as Rodrigo mentioned, it was a two-dimensional spectra that we recorded with two cross dispersive elements. But then, for different reasons, we have to move to other techniques. The main reason was SNR of the system. So a goal was to increase SNR of the NIT camera. So first, a classical way was to use a non-uniformity correction. It means that we adjust the gain and the offset for each pixel. It was done by NIT for us. And then we do regular background removals. We also did some lock-in modulation, so you can see it here, maybe the small vent that was chopping the current, the beam at 113 Hertz, and with acquisition at 1000 frames per second, and immediate demodulation, so we had a live streaming of images and spectra. And then what we did, what you can see on this portion here, is that we decided to spread the spectrum vertically. And you can see the difference here on this image. You can see the spectrum, I mean the beam hitting the detector. That is on a narrow number of lines. And you see on the spectrum that you have some noise on the background. And just by spreading the beam a little bit more, as shown here, then you can clearly see a huge reduction of the background noise, so increased signal to noise ratio. And all these techniques allowed us to, for example, for methane, to reach the natural concentration of methane in the air. So the next step was to make flare fly, and we brought it to an helicopter, and we did a 3 days long campaign in between Sweden and Denmark. It's called the Kattegat Channel, where you have hundreds of ships going through the channel every day between the Baltic Sea and the North Sea. And the helicopter is just following ships and flying directly in the plumes of the ships. You can see it here. And I'll just show you some results we had. So we can see for methane, for example, that we had at first no signal detection. And when the helicopter goes in the plume, then we start to get some signal. And in this case, the helicopter just went 5 times in the plume. And we can zoom at one of the signals here. We have our flare system in red. And in gray, just underneath, we have a commercial sensor based on a QCL, which was tuned for methane. And we see that both just measurements agree perfectly. So this project was a success due to the collaboration of all these partners in the bottom. Sensor was doing the multipass cell, which is just underneath the system here. It's a 10-meter long pass cell, which means a long interaction length and better noise floor for the measurement of molecules. NKT did provide supercontinuum source, which is delivered through a fiber that you can see here going through the system and just entering our spectrometer there. Thorlabs, of course, provided some equipment, lenses, mirrors. Yeah, we also did collaboration with DTU that did another light source as NKT. NKT supercontinuum went up to 5 micron, and DTU made a prototype up to 10 to 12 micron, but that was a little bit too big and too heavy to be placed on our system. So I think it's more or less all for Flare. If you have questions, don't hesitate.
Okay, thank you very much, Lauren, for presenting this super interesting application, for cameras of NIT. So, okay, maybe this is also the right moment to introduce you another company in the meeting. So, Linda from IRNOVA, would you like to explain the capabilities of your company? I think you also have a slide, right?
Yes. Let's see. You see the presentation? Yeah, now we see the presentation.
Yes, please, Linda, focus in one slide only.
Yeah. So I will start by showing a very beautiful infrared image of Stockholm, taken with one of IRNOVA's detectors. IRNOVA is a Swedish supplier of infrared detectors, and we are privately owned, and we have been around since 2007. But we have more than 30 years of experience in detector manufacturing and R&D. And we have highly skilled personnel and excellent clean room facilities in-house that we use to fabricate our detectors. So our main technologies are for long wave detection, small pitch QUIP detectors, and for mid-wave detection, that is 3 to 5 micron, high operating temperature type 2 superlattices. And thanks to the high operating temperatures of the superlattices, we can make the smallest infrared detector, cooled infrared detector in Europe. It's 230 grams. And there's no compromise on the picture quality. It has 20 millikelvin NHD, and it's very low power consuming. So I was thinking it would fit nice to the NIT small detectors, but with better performance. That was my. And I should say also, we have tailored detectors for gas sensing for those ones who are interested.
Okay, thank you very much, Linda, for this short presentation about the capabilities of IR Nova. And now let's go to the last speech of today. So, just Thorsten from Diamond Tech. Would you like to share your screen?
Yes. So, here we go. Hello, everyone. My name is Thorsten. I'm one of the founders of Diamond Tech. And based on mid-IR spectroscopy, we have developed a new medical device that can measure blood glucose non-invasively. That means without finger pricking. So we are on the application side of using the technology. Diabetes is a chronic health condition that affects how the body turns glucose into energy. And more than 450 million people worldwide suffer from this disease. To manage your sugar levels, you have to measure your blood sugar. And you do this today as you did the last 30 years, which means you prick your finger, you get a drop of blood, you put that drop of blood on a test strip, you put the test strip in a device, and then you see your blood sugar value on a display. Our solution is non-invasive. From a user's perspective, it works like the fingerprint sensor on your mobile phone. You put your finger on our sensor, you wait for 10 to 15 seconds, and then you see your blood sugar value without pricking your finger or any drop of blood. We do the development in 3 steps. Step 1 is a tabletop shoebox size device that we use to show that the technology works and to do clinical studies. Step 2, handheld device, the size of your mobile phone, a little bit thicker. This is actually the first device that we want to commercialize. And a little bit in the future, we want to get everything in an integrated sensor. You can put in a wristband, you can wear the wristband 24/7. It measures automatically every 5 minutes and can give you an alarm if your blood sugar is too high or too low. How do we do it? We are using a tunable external cavity QCL. Actually, it's a head shock from a Daylight Solutions. And you saw one of our publications in that presentation. To shoot the beam. And here on the crystal, this is the finger. The blue pellet is the finger. So you put your finger on the crystal. The laser light enters the skin about 100 microns into the skin. It gets absorbed, the energy gets absorbed by the glucose molecule. It creates heat. The heat travels back to the crystal. The crystal is made from material that changes the refractive index when the temperature changes. So we have something we call a thermal lens here at this point. And then we are using a red laser beam, just red laser light, visible laser light that gets deflected. And then we use a position sensitive detector to detect the deflection. And the more glucose, the bigger the temperature change, the bigger the deflection. We call it photothermal spectroscopy. And the good thing is we don't need an IR detector because we are just measuring the deflection of the red laser light. You can see it a little bit nicer. Here's the headshot QCL from Daylight. It shoots, it shoots to the mirror, gets focused into the skin. Heat travels back to the crystal, thermal lens creates here, and then you have the red laser pointer and it gets deflected and we can measure that. On the right side, you see an actual prototype of the device where I did my measurements. You see it's covered so that no laser light can come out. Accuracy is always a big question then when it comes to non-invasive blood sugar measurement devices. We just did a study with 100 people and proved that we have the same accuracy as minimal invasive or invasive devices that are already out in the market. And here you can see a measurement that I did during that test, where you have the red line is the invasive measurements. The red halo is the error bar of the invasive measurements. The blue line is what we measured with our non-invasive device. And then we used the Freestyle Libre, these minimal invasive devices that you can put on your arm. They have a little sting that goes into your skin and it measures continuously. And we plotted against it. And you see it's all very much clinical accurate. At the end of the day, we are not doing it technology for the technology, but also to help the people. Here's a testimony I get from a mother of two who wrote me an email and said, I'm looking forward to the day when our kids don't have to finger prick anymore. I hate the stabbing, clicking sound the device makes. Yes, this was my very short presentation.
It was a fantastic presentation, and I love it short because I'm 4 minutes out of time and people are looking at me weird. What a fantastic meeting. Diamond Tech, Anna loves you, by the way. Anna is saying to me, I love this company. This is an epic meeting and we love what you do, but we want to help you. What can you do for them? What can they do for you?
As I showed in the roadmap of development stages, we are now at shoebox size level. We are halfway through to the handheld level. But what we need to do is to make the sensor smaller, to make the QCL smaller, and to make everything mass manufacturable. The good thing is demand is not our problem, but production is. So we already have 150,000 units ordered. We can easily go into millions of those devices. And now I have to see where can I get my QCLs in a very small size, mass manufactured. Where can I get the sensor in a very small size, mass manufactured? And how do I get everything into a wristband in the next 3 years?
We have a couple of anonymous questions, which I'm going to read for you. The first one is, what wavelength do you employ for glucose monitoring?
It's around 10 microns. We have a range of, for the tunable QCL, of 300 wave numbers, around 10 microns. We use 15 to 16 wave numbers in that range.
We have, by the way, that question was from Sumitomo Electric. I thought it was anonymous, but the name came afterwards. We have a question from Essent Optics, but the question is to IR Nova. Essent Optics, what's on your mind? Let me go ahead. Yes, it's okay. Sure. The next question is from Thorlabs. Reza, what's on your mind?
I have a question for Thorsten about QCL. Since it's a photothermal effect, does the QCL have to be tunable? Because I assume that is a big contributor to the size of it. And in general, how do you plan to put this on a wristband? You already mentioned this is a challenge. I was wondering if you had specific needs or ideas. And what would be the cost target? Sorry for multiple questions.
Yeah, so it doesn't need to be tunable. So we could well live with 15 single wave number or 15 single emitters on a chip, for example. And that would also be the way to make it very small. Target price is, and again, this is still in discussion, but for a minimal invasive device, Freestyle Libre, that will cost you around $150 or euros per month. So around 2,000 euros per year. So the device can cost up to 5,000 to 6,000 euros and will be still somewhat in the same range as the minimal invasive devices.
All right, we have one more question from Johannes from nanoplus.
Yeah, no question, just a comment, but I think we should talk about it because with the new sensor light technologies, it's more or less exactly in our target range.
Thorsten, Cees Micro-Optics told us, if you are doing something on mid-infrared, you need to put these people on a stage, and you really made a huge, fantastic way of closing this fantastic meeting. You know what is my conclusion of this meeting? My conclusion of this meeting is that we need to work together. We've been talking a lot about the reduction of costs. We've been talking about our volume production. This is not going to happen if we don't join forces. And EPIC is going to take action. With the support of the European Commission and the pilot line MIRFAB, we are starting the Mid-Infrared Alliance. This is a way of all the companies in mid-infrared to work together. And I'm just talking about shared booth in end-user exhibitions. I'm talking about having a way to develop a roadmap for the next 10 years. I'm talking about raising awareness of all the different applications that can be solved with mid-infrared technology. We have to work together. We don't know how we're going to do this. but we know that we want to. So if you have any ideas or suggestions, or you simply want to be part of this, send an email to Ana Gonzalez, ana.gonzalez@epicdasaso.com. She's going to be the master and commander of the Mid-Infrared Alliance. Mid-Infrared Alliance. This is going to happen. I don't know how, but this is going to happen. And I also would like to say this was a fantastic meeting. Really, it was. There's so many opportunities for collaboration. Many companies looking for micro optics for beam shaping and the packaging of the lasers or the packaging of the cameras. We saw also about specialty fibers for picking of the QCLs, the beam combining. And oh my God, the presentation from Mirza was like out of this world. And the coatings and the accurate optics filters. I think this is a huge room for cooperation. An amazing meeting with an amazing set of EPIC members. It really, really was. I really want to apologize because I was going to finish on time. And today it took us 9 minutes extra. But I think 9 minutes that were totally worth it. But the meeting is not over. Now is the most important part of the meeting. You need to follow up. There is a lot of opportunities, a lot of leads to follow up. If you want to get in touch with any of the participants today, just send me an email, jose.pozo@epicdasaso.com, and I will be more than happy to make the introduction. On behalf of a fantastic team of collaborators, a fantastic team of people expert in the laser industry, in the photonic integrated circuit industry, in the quantum industry, in the optics, in the laser, everyone is here to offer you support. I work with a fantastic team of experts and I love working with them. And also I love working with 670 EPIC members. Just please make sure, only one little favor, have a look at our upcoming meetings, and if anything is interesting for you, register yourself, because I don't want to keep sending emails. I mean, it's the spam folder of most of you already, so I don't want to. Just please register yourself for the meetings that are relevant for you. I have all the information there on the website available. That's my little favor I ask you in return of all the amazing effort that the EPIC is doing for the industry. Until the next time, wear your mask, wash your hands. We're going to be traveling very soon. Laser Munich is going to happen. Until the next time, take care of each other. Bye-bye.